Our previous lecture talked about galaxy collisions. So I want to expand that. I ended with the idea that when galaxies collide, that the collision could actually strip a lot of interstellar medium from the galaxy. The remaining galaxy has very little interstellar medium. Now, if that's the case, then what can possibly happen is without interstellar medium, you don't make new stars. So you can take a galaxy, it used to be an SB or an SC, you have very little interstellar medium left. You don't make as many stars, so the core dominates way more than the spiral arms, and that becomes an SA or even an S0. If you strip too much of the interstellar medium, for example, if galaxies actually pass through each other, they keep going, but the interstellar medium gets ripped behind, then you have two clumps of things here, stars primarily, that have almost no dust and gas, so they quit making stars. So that means that that's going to be basically what an elliptical galaxy looks like. And so elliptical galaxies could potentially be formed from these galaxy collisions. And so this is something that's really interesting that computer simulations show what can sometimes happen is that when these galaxies collide, you strip all this interstellar medium away, and then all you have are stars, and so you end up with an elliptical galaxy. So your book actually indicates something slightly differently than this. Your book says that when galaxies form, you have all this dust and gas, all this gas, and either it swirls together and makes a whole bunch of stars and makes some stars, and all the dust stays there. And what happens is you make a few stars, you have kind of a burst of star formation, and you just keep all the gas and keep making stars for a long time. And in that case, you have a spiral galaxy, or some mysterious thing happens causing all the gas to suddenly make stars all at once, and then you don't have any more gas to make stars, and now you have an elliptical galaxy. The question that's always been there is, what mysterious thing would happen that would make a galaxy do one versus the other? And so in science, that's always a problematic thing if you do that. And so what we're going to do is we're going to say, well, wait a minute, maybe that's not what happened. A couple of friends of mine, Pam Markham and Mike Finelli, that used to be at TCU, they now both work for NASA, were studying a large number of elliptical galaxies, and they found that almost none of these galaxies showed no evidence of a collision in the past. They all showed evidence of collisions. They were all part of systems that had collisions. There were only a few of them that weren't. And so that suggests that most galaxies actually probably form as spirals, have collisions, and then they get ellipticals. Now, there were a few that actually acted like they might have directly formed into ellipticals, so that does probably still happen. But the other thing that we do when we look farther and farther back in galaxies in time, farther away is backwards in time. So farther and farther away when we look at galaxy clusters, we notice something different. Nearby, about 5% of the galaxies that are in rich clusters are spirals. Now, rich clusters are the ones that have a whole bunch of galaxies all close together. Far away, about 30% of the galaxies are spiral. Now, what does that mean? The farther away you look, the farther back in time you're looking. So if you look at something a billion light years away, you look at something that's a billion years younger than it is today. If you look at something 5 billion light years away, you're looking at something 5 billion years younger. If you look at something 10 billion light years away, you're looking at something 10 billion years younger. And so the farther away we look, the more spirals are in galaxies. Rich galaxy clusters, that is. And so that means that as time passes, there's fewer spirals. Why are there fewer spirals? Well, one possibility is collisions. In fact, one thing we notice is that big, rich clusters almost all have one or two giant spiral, or rather giant elliptical galaxies rather in the center of them. These are these giant CD galaxies, that are here. And so these giant elliptical galaxies in the center of a lot of star clusters tend to suggest that, in fact, we had a lot of collisions that created them. In fact, some of these galaxies can be enormous, that would result from a whole bunch of spiral galaxies running into each other and kicking all the interstellar medium out. So what happens to all the interstellar medium? Got to go out into space between the galaxy clusters. Again, the Hercules cluster has, on the outside of it, there's spiral galaxies, but in the middle of it, there's a whole bunch of elliptical galaxies. Again, the middle is where you get most of the collisions. And so, again, this suggests that this is the sort of thing that really happens. A coma cluster, you have a whole bunch of spiral galaxies on the outside. In the middle, you have some really giant elliptical galaxies from collisions and Abell 22818, giant elliptical and then spiral galaxies around the outside. Sometimes something like the local group, all the galaxies will probably merge together eventually and make an elliptical galaxy. And they found several of these, and they call them fossil groups. So NGC 6482 looks like just an elliptical galaxy. It's almost certainly what's left over from a group of galaxies all merging. So what happens to all the interstellar medium? It gets kicked out. So if you look at Abell 2029, you notice this is an elliptical galaxy that's in the middle of a group of galaxies, but surrounding it is a whole bunch of really hot gas that got spewed out with a lot of energy. And so that's glowing in X-rays. We look at other galaxy clusters, and so this is a combination image here. X-ray group, X-ray are the colored stuff, and all the little yellow things are galaxies. And we notice that in these galaxy clusters, right near the center of the galaxy clusters are a bunch of elliptical galaxies, but there's all this gas spewed out all over the place into the galaxy. So this intergalactic gas or intracluster gas, which is out there. It's hot, it's energetic because it's been ripped away from galaxies, and so it's glowing in X. We also can see places where we can measure the Doppler shift of these things and realize it's not just gas, but stuff's moving too fast, indicating there's a lot of dark matter that's also been pulled out of the galaxies. So again, your book has kind of a graphic here where two galaxies run into each other, or two clusters run into each other, and they leave behind dark matter. Okay. And in fact, turns out these galaxy clusters have too much mass. You add up all the mass of the galaxies, the mass of the intergalactic gas, and it's still not enough mass to explain some of the gravitational lensing that occurs in there. And so that means the galaxy clusters also have a lot of dark matter in them. Just like galaxies are mostly dark matter, galaxy clusters are mostly dark matter.